Good afternoon, ladies and gentlemen. We are from Faculty of Agriculture, 11 Maret University. I am Vita, here with two students in our team, Nadine and Kintavi. We would like to present the results of our research, which is entitled Effect of lignocellulolytic microorganism isolated from the peel of cassava, rice straw, and sawdust for the composting process of rice straw. It is well known that application of compost affects soil fertility and health, including supplying macro and micronutrients, improving soil physical and chemical quality, increasing the population density, diversity, total biomass, and metabolic activity of microorganisms, and eliminating soil pathogens. The quality of compost depends on the material and technology used during the composting process. It is important to produce compost in short period with high quality. However, the composting process will take a long time if only rely on indigenous decomposing microorganisms. On the other side, immature compost will harm the soil and plants. Some previous studies have reported that one of the efforts to speed up the composting process and to improve the quality of the compost is by adding bioactivators. The mission of our research is to obtain effective aerobic bioactivators. So the exploration of isolate of microbial decomposer from various natural sources is needed. Based on this background, the present study is aimed to isolate lignocellulolytic bacteria and fungi from peeled cassava, rice straw, and sawdust, and to examine their capability as bioactivator in the composting process of rice straw. For the next slide, will be presented by Nadine. Please, Nadine.
Thank you, Profita. The next slide, materials and methods. The first step was the preparation of the sources of isolate. Sources of isolate of lignocellulolytic microorganisms and general bacteria were obtained from the outer peels of cassava, inner peels and fines of cassava, dried rice straw, the mixture of mahogany and sengon sawdust, with a ratio of 1:1 and 1-week-old rice straw compost. For the 1-week-old rice straw compost, the sample was taken from the center of the compost pile when the temperature reached about 60 degrees Celsius. The second step was the isolation of lignocellulolytic bacteria and fungi from all those sources using a serial dilution of physiological saline solution, then inoculated the sample by using spread plate method to 5 types of media that were carboxymethyl cellulose, lignolytic selection media, Omeliansky, nutrient agar, and starch casein agar media. In addition, several small pieces of each sample were also inoculated directly to the respective media. After incubation for a week at room temperature, the population density and morphology colony were observed. Each type of each colony in each medium was then purified and propagated in liquid culture from the same medium to be used as bioactivator. The next step was setup of rice straw compost and application of bioactivator. A total of 100 kg of dried rice straw was chopped, soaked in a basin of water, and arranged into 2 piles. The first compost pile was a control treatment, while the second compost pile was treated with the addition of bioactivator. After 2 weeks of piling, the 2 compost piles were turned and moistened. At this first turning, the bioactivator was applied. The second turning was conducted on day 28, and then composting was terminated on day 60. During the composting process, we observed some variable of composting condition, and at the end of composting, we conducted analysis of chemical characteristics of compost products. The next slide will be explained by Kintavi.
Thanks to Nadine. Then I will continue for the result and discussion next section. We have 3 points from result and discussion. In table 1, we can see it's about isolate from the mixture of mahogany and sengon sawdust in ratio of 1:1. We observe the colony morphology, including the number of colonies, shape, elevation, surface, opacity, margin, and color from 5 sources of isolates. But in here, we only show the data from the morphology colony from the mixture of mahogany and sengon sawdust. Then we continue for table 2. This table shows the colony diversity and population density of isolated lignocellulolytic bacteria and fungi from sources of isolates. In total, there were 55 colony diversities found, consists of 25 types of bacterial colonies and 30 types of fungal colonies from 5 sources of isolates. The growth of isolates from the mixture of mahogany and sengon sawdust on Omeliansky media show the highest colony diversity and population density compared to other isolate sources. And for general bacteria and actinobacteria, isolated from 1 week old compost that grown on NA and CA media shows similar types, but the population density was higher on CA media. On the left side are some photos of lignocellulolytic microorganism isolates. On the right side are some photos of pure culture of lignocellulolytic microorganism. In table 3, we can see the composting condition. The data show that on day 7, the 2 compost piles reach the highest core temperature, and then on day 14, temperature decreased. The bioactivator was applied to the pile of compost treatment on day 14. The effect of addition of bioactivator was observed on day 21 and 28. The temperature of compost treatment increased, while the temperature of compost control decreased. This finding indicated that the application of bioactivator resulted in the extension of thermophilic phase in the composting process. The thermophilic phase in the composting process is very important for the elimination of the harmful pathogens and viruses. The pattern of moisture content between the 2 compost piles were similar level during the whole period of composting. The initial pH of rice straw compost was the same, and after undergoing the composting process for 14 days, in the pH increased sharply. The increase of pH in the composting can occur due to intensive ammonia production in the early weeks of the decomposition process. After day 21, both compost piles decreased in the pH towards neutral until the end of composting. As I before, we can see the characteristic of compost product. Compost with bioactivator indicates high quality with CN ratio 15.2 and total nutrient 19.3% higher than compost control. The 2 compost products meet the quality standard for solid organic compost product according to the degree of the Agricultural Minister of Indonesia 2019. Next slide will be presented by Profita.
Thank you, Kintavi. Okay, at this slide, let me to conclude the results. The first point, isolation of lignocellulolytic bacteria and fungi from the mixture of mahogany and sengon sawdust on Omeliansky media resulted in the highest colony diversity and population density compared to 3 other sources. Point 2, general bacteria and actinobacteria isolated from the 1 week old rice straw compost that grown on NA and SCA media showed similar types, but the population density was higher on SCA media. Point 3, the rice straw compost product with bioactivator treatment indicated higher quality compared to the compost control. The last point, application of the mixed culture of all isolated lignocellulolytic bacteria and fungi as bioactivator in the composting of rice straw resulted in the extension of the period of thermophilic phase, increasing the rate of composting, and improving the quality of compost. To continue the present research, these are our research plan for near future. Ladies and gentlemen, that is all our presentation. Thank you.